So question 24 is a geometry problem. So in this question, we're given a circle of radius 2, and it's cut into 4 congruent arcs. And the 4 arcs are joined to form the star figure below. And we want to find what is the ratio of the area of the star figure to the area of the original circle. So we basically want the ratio of the area of the figure on the right to the area of the figure on the left. What we can do is we can first take care of the easier one, right? Like the circle, we have a circle, and we're given as radius 2. Well, if we wanted to find the area of this circle, well, that's not too difficult, right? We would just do pi r squared. So pi times 2 squared, and you get 4 pi. 4 pi is the area of the circle. So now all we have to do is find the area of the star figure and then take the ratio, and we would be done. So finding the area of the star figure might be slightly more tricky, kind of. But the idea is, so you have your star figure, right? Oh, that doesn't look very pretty. So okay, we'll just say something like that. So if whenever you have a shape that's weird like this, that you can't you don't have a formula to calculate it, right? A square, the area of a square is side length squared. If you have an area of a rectangle, you just do width base times height. And if you have a triangle, you do a half base times height. But a lot of the times you'll be given weird figures like this star figure here that won't have some explicit formula that you can just directly apply to get the answer. So a lot of these, to find the area of irregular shapes, they're always usually 2 main methods. Either you take the figure and you split it up into figures you know how to handle, or you take that figure, you take a bigger figure and you imagine chopping off stuff to get your current figure. So in this case, we can imagine if we were to build a square around this, right? We can kind of treat it as the area of the square. So square minus the sum of these red quarter circles, minus red quarter circles. And that would just give us the area of the star figure. And the reason this is much better for us to handle is because we know how to find the area of a square, and we know how to find the area of these quarter circles, right? So we can find the area of the star figure. So we're given that this this circle has a radius 2, right? So you have a radius 2. And that means each of these lengths, this length here is 2, this length 2, this length here is 2, and so on. So that tells us that the side length of the square is going to be 4. So the area of the square is just 4 squared, which is 16. So to find the area of the red quarter circles, notice that we have 4 of these red quarter circles, right? We have 4 of them. So we can just do 4 times the area of one of them, just by symmetry. So the area of one of these quarter circles, normally the area of a full circle would be pi r squared, so pi times 2 squared. But since this is a quarter circle, we're going to have to divide by 4. So we can kind of simplify this, cancel off a 4 there, and you would get 16 minus 4 pi is the area of the star figure. So star figure area. And now we're basically ready to answer the question, which is, the question asks, what is the ratio of the area of the star figure to the area of the original circle? So we found that the area of the star figure is 16 minus 4 pi. And the area of the whole circle is just 4 pi, which we found there. So we can cancel off a factor of 4 in the numerator and the denominator. So on the numerator, we would get 4 minus pi, and the denominator, we would get pi. So our ratio would be 4 minus pi divided by pi. And that would give us choice A.